Welcome to Mechanical Tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about enclosure door latch. I am going to show you how to create this component in SolidWorks. Also, I am going to show you how to create the drawing of this component. So let's start now. I have taken a SolidWorks new part file. Select the front plane. Take center point rectangle. Here rectangle is 40 by 50. Go to sheet module. So sheet thickness I have taken 4 mm. So here we have to verify the bend radius. So it should be equivalent to sheet thickness. And K factor is 0.45. Select edge flange. Select two edges and angle is 45 degrees. Here we have to select bend outside because it is moving inside. Since it is 45 degrees, we have to select bend outside. Now we have to edit the sketches. Keep it normal. For visibility, we have to keep it in isometric and select this corner and move a little bit inside. Now keep it normal. So this edge is 35. This is 7 and come out of the sketch. So it is automatically modified according to the top flange. So we have to just move inside. So we have to modify this dimension also. So we have to keep it in ISO and we have to verify whether this direction is correct or not. Now come out of the sketch. So here. Now we have to create this edge flange. So this is 90 degrees. So keep it in top view. You have to see the direction. So we have to select material outside. Keep it in ISO. Now we have to modify the sketch. So you have to give dimension from this edge to this line. It's 55. Now I'm going to create this flange. So it is 90 degrees. So here we have to verify the bend direction. So keep it on top line. So it is moving outward. So here we can keep material inside since it is a 90 degrees bend. Now we have to modify the sketch. Keep it normal. Here we have to delete this line. Select this line. Remove the constraint. Here also select this line. Remove the vertical constraint. Simply move the other sides. Now select these two lines. Make it equal. And select these 2 points. Make it horizontal. So now these are symmetric. So the angle between these two lines is 45. Now it is constrained. Now we have to draw 3 lines. Select this line and this line. Make it vertical and equal. So this is a 69. $76. 76 and 69, 45 degrees. Now we have to come out of the sketch. So this is created now. Now I am going to unfold the component. So select this flat face and collect all bends. Say OK. So it has become flat. Now select this face. Keep it normal or keep it front. Here we have to make a cutout. So select cut extrude. Select this line, convert entity, and this line, convert entity. Join 2 lines. Go to trim entity, select corner trims, select these two lines. So this V shape is to have a exact sharp edge during cutting, either blanking or laser cutting. So the sharp edges is required. So this is not preferable, this edge. So we are making a sharp edge. Draw a center line. So we have to make sure this it is horizontal. Select mirror entities. Say OK. So now we have to link to thickness and say OK. See, this is a sharp edge. Now we have to create these sharp cutouts. So select this face once again. Go to sheet metal, cut extrude. So select this edge convert entity and select this edge convert entity. Go to trim entities, select corner trim. Here we have to mirror this sketch. So select mirror entities and select this center line. So this is not selected. Now select these 2 points. So it is 38. It's 45. Come out of this sketch. So we have to always link to thickness while creating a cutouts in sheet metal. Now once again select this face, sheet metal, extruded cut. So I am going to make this rectangular cutout. So since it is inclined, instead of taking rectangle, we have to take parallelogram. Select these two edges and just place it over here. So this is easy. If you take a rectangle, it consumes a time. Even if we make a simple line and make a rectangle, it takes time to constrain. Now select these two lines, this edge and this line, make it perpendicular. Eight mm, 11 mm and 6 mm. Now draw a center line. We have two mirror entities. So select this rectangle. So this is mirrored. Say OK. Select this face. Go to extrude cut. Now select this line. Right click. Select midpoint. Go to smart dimension. Select this edge. So this is 38. Select this line. Select this line. Select midpoint. Go to smart dimension. Select this edge. 38. Select these two line. Make it equal. Now come out of this sketch. Now we have to create these holes. Select this face. Go to sheet metal module. Select simple hole. So it is 6 mm. Now go to edit sketch. Now make a center line. Go to mirror entities. Select this circle. Save. I am going to fold this component. Collect all bends. Say this is. Now I am going to add this flange and this hole. Select edge flange. Here we have to take a bend outside. And it's 20 mm. Here, while creating this whole feature, either we can unfold this component and we can create, or else we can create in folded state. So at this moment I am creating in folded state. But best practice is we have to unfold and create the hole. So it is 6 mm. So select this midpoint and this midpoint, make it vertical. Select this midpoint and this point, make it horizontal. So it is constrained now. So it is 6 mm. Say OK. Now I am going to add fillets. So it's 2 mm. Select all sharp corners. So this final component is ready. See here. So this is the flat pattern. Next I am going to create the drawing. Taken a A3 sheet. So now I am going to insert this component. So keep it in isometric, shaded form, scale 2:3. Now once again insert this component, front view, 2:3. So right side view and bottom view. See, this lies in solid form, so I'm going to change this to tangent edge with font. See here, it is changed with construction lines. Now I'm going to place the dimensions. So annotation, select smart dimension, select this edge. Since it is a square, we can straight away type SQ. So we have to show the overall dimension. And this edge to the center. And holes from center to center distance. and this overall height. So don't place the center marks. After placing the dimension, it is better to show the center marks. Otherwise, sometimes when we modify the model, it goes to the dangling dimension. So to avoid such problems, we have to place center mark in the last. And we should not select the center marks for placing the dimension. We have to always use the circular edges to place the dimension. So this is 45. So same cutout we are using both sides. So we have to mention 2 into x. So we have to show these cutout dimensions. So you can place outside. Here also we have to type 2 into x. With the direction, we have to click at this point. This is also 2 into x. See here also we have 2 holes. So we have to place 2x. Now we have to show this radius. So it's a 2 mm and we have to mention typical. Instead of showing everywhere, we have to mention typical. So it should be always 60 degrees or 30 degrees. Any dimension. We have to place it in these 2 angles. So here we have to show this dimension from this place to this. So we are not able to pick this corner point. So what we have to do is we have to create one point at this intersection point. So select these 2 entities, this arc and this line. Go to sketch, select point. So you can see one point is created over here. Now we can easily place this dimension. Select this point and select this point. So here we can place 2 into x. So we have to mention this angle. So select this line, select this edge, and this is 45. So center from that edge is 6 mm. This is 38. The hole is 6 mm. So here also we have to mention this hole diameter. You can mention 2 into x, or sometimes we can remove this diameter and we can type typical at one location. Now I am going to place at this view. So this is 20. See here, to avoid destruction, we can remove this edge. So we have to select hide edges. Now we have to place the center marks. So select this circle. So this is the best practice. We have to place it after completing all the dimensions. So here for center line, we have to select these two edges. So once again, select these two edges. So this is the final drawing, and we can add notes like this thickness of the sheet. Generally we don't mention sheet thickness with dimension. we have to always mention in the note like a gauge or sheet thickness. So that is the best practice. So finally, this component drawing is completed. I am going to share this drawing PDF file in the description. You can download before practicing. Thanks for watching.